Cool. So, and you still can't see me?
Nope.
Correct. Can you see my video, or should we just skip that?
I think just go on. Yeah, just go ahead, Mary, unless you needed to show
Okay,
something
great.
that you're holding or something
No,
like that.
that's fine. Don't worry about it. That's great. All right. So yeah, thanks everyone. Thanks for being here. Really nice to see lots of friendly faces. I'm going to talk about Lude, Lude, which is a tool that I've been working on for building games quickly, specifically 2D video games. And I found some amount of success so far. So in this talk, then I'll show a demo of building a kind of rudimentary breakout in about 10 minutes. And so quick overview of the talk though. I'll do a tour of Lude, just to orient us all. And then I'll talk about breakout, just so that we know what we're building. And then I'll talk about the techniques that Lude uses for letting you build games quickly. And then the piece of the talk will be demos illustrating these techniques for building quickly. So let's look at Lude. It's composed of two parts. There's an editor which runs on the desktop in the browser. And then the second part is the game which runs on your phone, your real phone, not a simulator. And so you can see the editor there on the left, and you can see me holding up my phone, running the game in the bottom right. And you can see, you will see in a minute, a kind of screen share of my phone, which is just for your benefit, so you can see what's going on the phone, but that top right part is nothing to do with Lude, it's just a screen share, so that you can see what's going on. So that's high level of the setup. And then the Lude editor itself, we'll dig into these pieces, of course, shortly. So on the left, you have kind of a live level editor, and I'll talk about what that means. And then kind of in the middle there on the desktop browser part, then you have a series of editors. You have a object editor, which lets you edit properties. You have a specification editor, I'll talk about what that means. And then we are currently looking at the code editor on the kind of middle right there. So that's high level. And then quick review on Breakout, if you've never played it or seen it before. So it's a game where the player controls a paddle. That's the kind of green bar at the bottom there. And they use it to try and knock a ball towards some bricks. And when the ball hits a brick, the brick's destroyed. And the goal of the game is to clear all the bricks. So that's Breakout. Lude uses 4 techniques for building quickly. Number 1, directly manipulating the game as much as possible. You use direct manipulation to make any edits that you want to make. Number 2, you play test on the device, and that is a separate device from the device in which you're editing. Number 3, it's a live environment, you know, on brand for the conference. So changes you make instantly available to try. And number 4, because it's 2023, it uses code generation. So let's get on with the demos. All right, so hopefully you can see video playing. Let me know if you can't. So I'm going to add the ball and then some walls to confine the play area. And you can see me just drawing the ball there. Nice yellow color, just resizing. And then I'm going to add the walls. I'm going to start with one wall, get it the right size. And then I'm going to get so it can't move by using the property editor there. And then I'm going to draw in a nice wash of color for the wall itself. And just as a reminder, on the right-hand side, you can see everything that's happening on my phone. So it's live, it's being updated instantly. Now I'm going to duplicate that wall, make more walls, and get those into a nice position. Now we've got the ball and walls. So a bit of editorial about what happened there. So we used direct manipulation, as you saw, to position the objects and to get them to the right size. to edit anything about an object, so its appearance or its data or its behavior, you start by directly selecting it first. So you click on the thing. So I found it's profound to see a problem in the running thing and just be able to click on the problem itself. You don't dive off into some other context like code or a separate image editor or something like that. As you saw, we draw directly onto objects, and so we see drawings in their real context, at the real size, surrounded by the real objects that they'll be in the real game. And one extra thing to say about this is that this direct manipulation in a level editor is definitely not new. It's standard practice for video games, certainly. But this feels a little more powerful because generally with traditional level editors, then the game runs in a separate window. So you level edit over here on the right, and then you run your game and you see the results in a separate window. But here, there's no context switch. So you just click on the thing that is actually running, and it's a lot more intuitive, I think. So that's technique number one for building quickly. Technique number two is you play test on the device. Let's watch the video. So we're going to add a play button that when the user taps it, then it will start the ball moving. So we set it to be so it can't move and can't collide with anything. And now I'm adding the behavior. We'll talk about how this all works, behavior definition later, but basically I'm saying when the button is tapped, then start the ball moving, the code was generated, and now as you can see in the bottom right there in the video of me holding up my phone, I can just start playing with it right away on the phone itself. It's been live loaded into the real running device. So this technique of playtesting on the device has some nice properties. So first you saw I can playtest the chain instantly. I can know how it will actually feel to play because I'm playing it on the real device. And then having two separate devices is also powerful for the editing. So you use one device to edit and the other to playtest. Like I say, you edit in the browser on a desktop, and then you playtest on your device. This two-device thing is really fluid, and I think the best way I can illustrate why it's fluid is to think about certainly the main alternatives that I could think of to this approach. And so number one is to introduce modes, where you switch between edit and play mode. So you can imagine that on the desktop there's like a toggle, you switch between edit and play, and yeah, don't need to go into why that sucks. Jeff Raskin's already told us about why that doesn't work very well. The other main option that I could think of was to have a single surface support both playing and editing simultaneously. So you click on a button, or you somehow click on it to trigger it in the same surface, so probably in the browser, I guess. This is a super heavy design burden, especially if you want to maintain the property of direct manipulation as much as possible. So for example, just one problem you have to solve. You need to allow a button to be both selected and also somehow triggered from the same surface. And there's like a million other overloaded inputs that you'd have to grapple with design-wise. Whereas instead, you could just, as I did, I just separated the job into two surfaces. On mobile, a tap on the play button triggers the button. On desktop, a click on the play button selects the button for editing. Super simple. That's part two is playtesting on the device. Makes things faster and more fluid to build. Part three is the live environment. Let's watch the video. So we'll now add the paddle, and we'll let the player move the paddle around by tapping on the screen. So we're just drawing in here, nice green color. And then we're going to add behavior. Again, we'll talk about how behavior definition works in a minute. So when the player taps the screen, the paddle moves slowly in the X and Y direction towards the location of the tap. So we're just going to generate that code and try it out. looks good. The paddle's moving around. You can see the button right there tapping on my phone. So what happened there? Well, everything's live and there's no compilation or reloading. So edits made to the properties of objects are live the instant that they're made. So, when I made the ball movable, they stop moving at that moment on my phone at that instant. And code additions or edits start running the instant that they're generated as well. So, when I got that code generated, as soon as it was syntactically valid, it was run and loaded into the live environment on my phone. So obviously this means you can try out changes right away, which is really nice. But I think the bigger advantage here in terms of quick building is that the game designer doesn't lose their place when they make changes. So the game state that inspired a change that you wanted to make is the state that the game's in when you make the change. So where all the objects are, you make the change in. And then once you've made the change to your game, then the game is still in that state, ready to go, ready to try out the change in the exact context and setup that inspired the change. So it's a really, really nice type feedback. Just the third reason that it's fast to build with Lude. And the fourth one that I'll talk about is code generation. Let's look at the video. So we're going to add a feature to give the player a bit more control over the ball. High level, when the ball hits the paddle kind of far to the left of the paddle, and we want it to sort of bounce off much more sharply to the left. And then when the ball hits the paddle far to the right, we want it to bounce much more sharply off to the right. So this lets the player direct the ball towards the bricks with more precision. So we're just writing in the prompt there to describe that behavior. And we're going to generate the code. And then we can try it out. I'm just unpausing the game there. And let's look at it playing. So you can see that when the ball hits far to the left of the paddle, it really kind of pings off at a sharp angle. So how does code creation work? Well, sort of high-level programming model, probably no big surprises, is binding event handlers to objects. So, for example, when a collision event happens between an object of type ball and an object of type paddle, then change the ball velocity in the way that is described. Now, the behavior for event handlers is defined in code, and you can either write this code by hand. We're looking at the editor right now. You can just type in there, that works fine. Or you can generate that code from an LLM based on the specification that's written by the user. And those are those pieces of code that you've seen me writing throughout the demos. Let's just jump back to the, okay, so that we've got it in our mind. So it's a piece of code like that. How does it actually work in practice? The user starts with select objects they want to define behavior for. So in this case, you can see the ball of the paddle are selected. And then they write the pros, writing which event they're talking about. So, a collision or a tick or whatever. And then describing the behavior that they want to happen in response to that event. So you can see that example of pros in the center there. And then if you want to debug, then you just put constant logs inside your handlers in a way that is fairly common, and the logs show up in the DevTools. So why are we doing code generation here? It's because it's faster, generally speaking, not always, but quite often. And this is for two main reasons. Number one, often the LLM is better at translating the designer's intent into code, the designer is. So for example, for me, it's better than I am at implementing geometric functions. So it can get to the idea express the idea more quickly and correctly. And second, it's just often quicker to type in the prose. This prose piece of code is relatively long, but it's still certainly shorter than the code. And quite often, the prose version is much shorter than the code that's required to implement it. So those are the two reasons it's quicker. And so it got to the point where I was like, well, if I can do code generation, I kind of want to do that given that it's faster. And so really the problem becomes mitigating the problems of code generation. And so this boils down to capturing the designer's intent successfully in code. So they have something in their head, they want to successfully capture it in code. Getting that translation is the problem. And so what Lude does is tries to support that intent and expression with a bunch of things. So number one, as we saw, the designer selects the objects they're talking about. In this example, the paddle and the ball. And the LLM therefore knows, it uses those as the type of prompt, and it knows what you're talking about. Second, the designer expresses their intent by repeatedly revising the specification. So if it doesn't, they type code, run it, or generate and run, and it's not what they wanted, they then edit the piece of prose. And I think this I found that this carries more meaning than a back and forth chat. It's sort of more dense meaning. And the intent can also be more precisely inferred from the prose that the designer wrote in than from the code that already exists. The code that already exists seems somehow more ambiguous. But at the same time, the specification is not everything. So the LLM is also still given the code to work from. And this means that if the designer sees a change they want to make in the code, they totally can. So let's say they want to tweak a constant or something, or make a bigger change. And that intent that they've tried to capture there does get carried forward into future versions. And so the LLM kind of does this, looks at the code, looks at the spec, and comes to some sort of agreement between them. And then finally, and I think this is probably the most important factor in successfully capturing intent, the LLM writes code using a game engine that's built into Lude. So this constrains it to one way of doing all the common things you do with 2D video games. So one way of drawing, one way of handling physics, one way of getting input, things like that. And this helps it retain internal consistency in the approach, the code that it's generating. And these Lude built-ins are the things that many games need. So, for example, you saw at the beginning that once I set the ball going, excuse me, the ball bounced off walls already. And that's because that's built into the game engine, because it's a behavior that is pretty common to video games. So that's the fourth reason that it's fast to build with Lude, is code generation. Let's watch the end of breakout video. I'm going to add a new object that will become a brick. I'm going to move it so that set it so it can't move. Got a nice orange color. I'm going to make a few more bricks. Then finally, I'm going to define that behavior of when the brick detects it has collided, the ball, move the brick down by 600 pixels. So this is in effect destroying it. So we generate the code for that, and we try it out, and there go the bricks. Lovely. All right, so that's breakout. Quick summary. So the techniques that Lude uses to build quickly, directly manipulating the game as much as possible. Super intuitive, often the quickest way to make the change. Number two, playtest on a device, so you can try change it right away. And there's you can actually feel what the real game will be like to play. Next, a live environment, so your changes are ready to try and see, and you don't lose your place, you stay in the context of where the game was in when you wanted to make the change. Then finally, code generation, often faster than writing the code by hand. Thank you very much. And I would like to say thank you also to my friends at Ink and Switch, who have been extremely supportive, kind of I guess, sort of emotionally and also through pragmatic ideas. Many of the best food discussions that happened in Switch. So I really do appreciate it. Thank you so much.
Okay, questions. I see we have one so far.
Hello,
Hello.
Can you hear me?
Hi.
Hi, I'm Remy.
I can hear you. Yes, thank you.
So, yeah, I already sent you an email to get in touch with you, but didn't do it yet. Yeah, I've been in the area of programming languages and games for about 10 years. So it's very good to see someone else thinks this is a nice combination as well. So, yeah, talked about another tool for game design as a case study for generic language technology. But what I was wondering is how expressive is this environment for creating games? Because I see, that, okay, you have colliders, you have things moving around. How can you sculpt the gameplay in different directions? This is kind of my question. What kind of different can you make with it?
Yeah, it's a really good question. I've made kind of 2D physicsy games like Breakout that we saw pretty successfully because there's a physics engine built in, and so that gives you quite a lot of the pieces that you need. I've also made much more document-like games where it has tables of information, graphs, and it's mostly just buttons and typing into text boxes and things like that. And that works pretty well too, because in the end, it's just a different rendering layout engine, really. It's still just objects that need to bind to event handlers and stuff like that. So I found it's relatively flexible. I feel sure that the big limit on its expressivity is much more about building things into the game framework than it is about the programming model or the editor. So, for example, if you want a really nice sprite editor, then that has to be written and built. Or if you want a nice animation engine, that has to be written. And so I think it's more like just building those batteries, if you like. That's the large amount of work.
So, one follow-up question is allowed?
Yeah. Wait. Yeah.
Okay, so I think that if you call this game prototyping, then you could call it a framework for prototyping and playtesting, which are kind of game design oriented. And maybe you can think about how such games, after they are a prototype and they're fun to play, that somehow you offer that up as something to then fine-tune and maybe add stuff on. But yeah, then I think if you do it like that, then it can be a tool for game design. So that's...
Yeah, I think that's a really good prompt. Yeah, thanks.
Thanks.
So I'm curious to hear how you think about communicating with the LLM, specifically when I think about how a game engine would communicate with LLM. There's considerations around how you create guardrails for the LLM, how you scope the context, especially with games where it's like a entity component model or whatever patterns you're using in the game engine. I imagine those would align quite closely with how you choose to negotiate the communication with the LLM. And so, yeah, I'm curious how you're thinking about that.
So you're asking about how the LLM understands the game framework?
Yeah.
Yeah, it's a really good question. So far, I've found giving it a readout of all of the interfaces of the APIs that it has access to, it's pretty good at using them. And so that can be mostly auto-generated from the game code, the framework code itself. I also have been experimenting with putting in the documentation, but the documentation itself is pretty meager at the moment, so that hasn't gone very far yet. It is fairly good at staying within the guidelines of the framework. Occasionally it kind of goes a bit, bananas and gets confused, but generally it can understand how it's supposed to use APIs.
All right. Hi, this is Will Creighton from Brown. And my question is, I saw that you had like the play button on the screen along with all of the other stuff from the breakout game. And I'm curious about organization. Like, let's say I wanted to have the play button on its own screen. You click play, the button disappears, and then I have the breakout game come up proper. Is there a way, is there some notion of like layers or other ways that I could separate these things out? Or when I'm editing, do I just have to have everything from every screen in the same space all the time? Like, what do you think? Either are there already facilities, or what are you thinking about for facilities to organize the game state when it's more complicated like that?
Yeah, it's an excellent question. I think this is one of the central questions around code generation that I've been grappling with, is that really the meaning is spread across the code and the prompt that the user types in, and to some extent the state of the game as well. And so keeping the relevant parts of that on screen at the same time is challenging. So I think the next version of this would look at that more deeply to let you essentially assemble a context that you need for your current problem. So exactly like you say, sometimes you just look at the code, but most of the time you want to see all three of those things. And having the editor be more adaptive to your context would be really helpful.
All right, thanks.
All right. All right, I think last call for questions. Thank you, Mary. Really cool stuff. It's nice to see it on stage here today. That was the final talk for our workshop. Can we get a round of applause for all of the presenters and for our volunteers who have been helping us through all kinds of exciting challenges and crashes and video streams and so on. I think this is the first year using Discord as well as the host, so it has not been completely bump-free, but honestly, it's gone better than I actually thought it would. So kudos to all of you for doing that. Thank you so much.